Welcome back, guys, to day 22. Is it day 22? I kind of forgot. But yeah, yesterday I didn't make a video because I was busy. Today I was also busy. It's Saturday today. Yeah, and because I'm already busy for like these 2 days, tomorrow I will like study for a lot. But right now I'm going to study, so don't worry, guys. I'll start studying now.
Back in the day with classic Roblox games that added zombies into their game, comes come from, oh my, for playing a game like this, it's actually so easy. Like, there's absolutely no challenge involved with this whatsoever. Wait, whoa, where did these big green guys come from? Oh my god. Why do I make these cringy intros, bro? Alright, let's think about this for a minute. Today's video is going to be about humanoids, which are basically special objects in the game where you put them inside of a model and that model becomes a character, or at least it gives the functionality of a character versus just a model of parts. Now, what do I mean by this? Well, basically, in any given Roblox game that has characters in them or have character functionalities, like basically with what I'm doing here, where I'm able to move around, I'm able to jump, I'm able to interact with the world as if I'm a character. This is all because I have an object that's called a humanoid that's inside of my character model. So if I go inside of the workspace and I go to my character, then there's going to be an object here called a humanoid. So this is what gives life to my character, I guess if you want to call it that way. And this can be said about basically any player or NPC that you see inside the game, like this zombie NPC over here. If I were to just open him up, then there's going to be a humanoid here, and also this noob right here. If I open this up, then there's going to be a humanoid object. So this is what makes the difference between a model full parts versus a character. So let me show you what this looks like if I actually delete this humanoid from this NPC. So if I do that, then there's a few noticeable differences. First thing, we don't see his name. He also kind of like fell to the ground a little bit, but he's not able to like move around at all. Like we basically got rid of the character functionality from this character. So now this noob is just a model that has a bunch of parts in it, and that's all this is. So once again, this is what gives differentiation. And humanoids are very complex, or at least they can be very complex. So there's going to be a lot of things to cover. But for the sake of this episode, what my goal here is to show you how we can implement humanoids inside our scripts, how we can modify them, and how we can use scripts to use humanoids to do whatever it is we want to do, whether that's changing humanoid states, whether that is taking damage for a player, or any of those sort of things. I think it's important to know how to do this inside our own scripts. So that's going to be the goal for this episode. So with that being said, let's now go ahead and go straight into implementing. Now that we understand it, let's implement humanoids inside Roblox Studio. So to start off with this video,
Humanoid. Okay, this is what I like. Humanoid.
I'm going to show you a couple of very basic but also essential properties that we will use a lot with humanoids. And I think you've already seen some of these properties that we've used throughout the entirety of this tutorial guide. So I'm just going to hit play really quick and show you what these properties are. So if I were to go to the workspace, go and open up my character, and we should have a humanoid inside here. So if we click this, then there's going to be all these properties that we can work with for this episode. But so if our very basic but also essential properties that we will use a lot with humanoids. And I think you've already seen some of these properties that we've used throughout the entirety of this tutorial guide. So I'm just going to hit play really quick and show you what these properties are. So if I were to go to the workspace, go and open up my character, and we should have a humanoid inside here. So if we click this, then there's going to be all these properties that we can work with for this episode. But some of the properties that are going to be very essential are the ones down here in the game category. So one of them is health. Obviously, that's how much health you have in the game. Then you have things like walk speed, which is how fast or how slow you can walk in the game. And then you have jump power or jump height, which is how high you can jump inside the game. So we can change these properties directly inside of our humanoid, either using scripts or just changing it right here. Like if I were to just go to test and then go to the server, open up my character and go to the humanoid and then change, let's say the walk speed to 32, and I decide to change the jump height to 15, and then if I were to, let's say, change the health, so I have to change the max health to 200, and then change the normal health to 200, then that's what I would do. I'll explain what this means in just a little bit, but if I were to now go into the game, then I am running a little bit faster, and I'm also jumping a little bit faster because of that too. So that's how we're able to change some of the properties here. But now we show you what we can do through a script example. So I'm going to hit stop, and what I'm going to do is go to start player, and I'm going to insert a local script inside of starter character scripts. So as you remember, anything that's inside of starter character scripts is going to show up in our character in the workspace every single time our character loads into the game. So what I'm going to do is let's make a system where if we press a certain key like R, then it's going to add stats to our humanoid, like our walk speed, our jump power, and our health. So we can do that using user input service. So what I'm going to do is say local user input service equals game colon get service user input service.
Oh dang, this is gonna be like very fun. Okay. I wanna make like an enemy and I can kill him for an item to get a loot. So guys, I'm gonna go eat first, okay? I'll see you guys after I eat. Bye bye. So hello guys, I'm back. I'm gonna continue studying.
Just like this, and I'm going to say user input service dot input begin and colon connect function open close parentheses input. And input. If we press a, as you remember, anything that's inside of starter character scripts is going to show up in our character in the workspace every single time our character loads into the game. So what I'm going to do is let's make a system where if we press a certain key like R, then it's going to add stats to our humanoid, like our walk speed, our jump power, and our health. So we can do that using user input service. So what I'm going to do is say local user input service equals game colon get service user input service like this, and I'm going to say user input service dot input began colon connect function open close parentheses input, and we're going to enter just like this. So we're going to check.
Input service.
What the key is, we're going to say if input.keycode equals enum.keycode dot, let's say R. Then here's what we need to do now. We need to first locate our character, and then we're gonna get our humanoid. So what I'm going to do is say local character equals script dot parent. Because as you remember, anything inside of character scripts is going to be a child of our character model inside of the workspace. So this is how we can locate our character. And then we're gonna locate a humanoid by saying local humanoid equals character colon wait for child open close parentheses humanoid, just like this. And so now what we're gonna do is basically just change a bunch of properties here with humanoids. We're gonna say humanoid dot walk speed, just like this. And I'm just going to take whatever the value currently is and add, let's say 16 to it. I'm gonna drop a line and then say humanoid dot jump power plus equals, let's say 20. Now here's what I'm gonna add here for jump power. So when we were playing the game, there were two settings called jump power and line and then say humanoid dot jump power plus equals, let's say 20. Now here's what I'm gonna add here for jump power. So when we were playing the game, there were two settings called jump power and jump height, I believe. So if I go to humanoid, show you jump height and jump power. So we're not using jump power as like a unit of metric. We're using something called jump height. And this is what's set to by default. But what I would actually say is we should use jump power because I think it's a more accurate measurement that aligns with something like walk speed and health. And by default, this is not true. So this is a setting we have to configure so that we have jump power. And we do that in the game settings. So if you have your Roblox game published, then we can go to home and go to game settings. And then down here into world, there's this jump setting here where by default it's set to jump height. But we can actually check jump power, which looks like this is set. And by default, it's around 50 if we round it down. So now if we hit save, then we can affect the jump power or the jump height using the jump power property. I hope that makes sense. So now if we go in Roblox game published, then we can go to home and go to game settings. A unit of metric. We're using something called jump height. And this is what's set to by default. But what I would actually say is we should use jump power because I think it's a more accurate measurement that aligns with something like walk speed and health. And by default, this is not true. So this is a setting we have to configure so that we have jump power. And we do that through the game settings. So if you have your Roblox game published, then we can go to home and go to game settings. And then down here into world, there's this jump setting here where by default it's set to jump height. But we can actually check jump power, which looks like this is set. And by default, it's around 50 if we round it down. So now if we hit save, then we can affect the jump power or the jump height using the jump power property. I hope that makes sense. So now if we go into test and play, then what we should see is if we hit R, then it's going to increase our speed and also our the jump power or the jump height
It doesn't work. What the hell? No.
using the jump power property. I hope that makes sense. So now if we go into test and play, then what we should see is if we hit R, then it's going to increase our speed and also our jump power. And if I do it again, then it's going to make me go even faster, and then just do it again and again and again and again. And I'm just gonna, I can keep on going with this, but I think you get the idea here. Now, there's two properties for health. One of them is max health, and one of them is normal health. So the difference here between max health and normal health is max health is obviously how much health you can have in total, and health is what your health currently is. Because as you know, Roblox has a system by default where it's like you increase health ever so slightly by the second or by the millisecond. So if I was to change my max health here to 200, then my health is going to stay at 100 because I have to update this health value to 200 as well. Now I'm in the client, so I actually have to be in the server for this to be effective. So if I go to the humanoid and change the max health to 200, then as you can see, my health is slowly being incremented upward until it reaches 200 for the max health. But I can just change this to 200 so that it's the max. Now if I were to try and change the health to 200, then as you can see, my health is slowly being incremented upward until it reaches 200 for the max health. But I can just change this to 200 so that it's the max. Now if I were to try and change the health to something that's above the max, like let's say 300, then by default it's going to go to the maximum health that we are allowed for our character at this current moment. So that's basically some properties that are pretty essential to humanoids. But now we're going to cover some more things that you can do with scripting humanoids. The next thing I'm going to show you is humanoid states, and this basically allows us to see how our humanoid is interacting with the world as we currently speak if we were to check up on it. So some examples of humanoid states are things like walking or running, and also things like jumping, things like swimming, climbing, and all of those sorts of things. So we can do that through our scripts by detecting our state change in our humanoid. So what I'm going to do is hit stop, and I'm going to insert a new script just for the humanoid state changes. So I'm just going to insert another local script inside of our starter scripts. I'm going to rename this to state change, and I'm going to rename our local script previously to change stats just like this. And so now what I'm going to do with state change is I'm basically just going to go to our previous script. I'm going to copy the same thing we had last time with character humanoid, and I'm going to paste it inside here. So now what we're going to do is say humanoid.state changed is I'm basically just going to go to our previous script. I'm going to copy the same thing we had last time with character humanoid. And I'm going to paste it inside here. So now what we're going to do is say humanoid.state changed connect. function, open close parentheses, enter. Now this takes in two parameters. The first one being what was the state prior to the new state change. So this is going to be called old state, just like this. And the second parameter is going to be the new state of the state change. So I'm going to call this one new state. Now if we were to just print this out so I can show you what this looks like. So we can first print out old state, and then we're going to separate this with a comma by saying new state, just like that. And now if we were to go into the game, hit test and play, then what we should see in the output is first thing on the left side, it's going to be our old state, and what's on the right side is going to be our new state. So right now, our current state is running just like this. And if we jump, let's say, then it's going to change a bunch of things. So what I'm going to do is clear the output here so I can show you what it looks like when we jump. So if I jump, then it first starts by going from running to jumping. Then it went from jumping to free falling. So free falling means like you're falling down into the world. And then we went from free falling to landing, and then finally we went from landing to running. So all of these state changes happen within the span of like a second when we jump and then we fall back to the ground to land and then go back to our running state. So most of the time, our humanoids are going to be running. They're going to be in the running state. But like I mentioned, there's other states like climbing and also swimming as well. But those are going to be very uncommon compared to just running and all these other sorts of things. So we can do some pretty cool things with these local scripts, which I'm going to show you later in this episode. But that's the kind of something I want to add there for humanoid state changes. Now we can detect what these states are to perform certain actions. Like let's say we are currently jumping, then we want to add a double jump to whenever they decide to jump again. Once again, I'm going to show you how to do this later. But let's say we had an example of basically checking what the new state is. So we can say if new state equals, and then as you notice down here with the jump again. Once again, I'm going to show you how to do this later. But let's say we had an example of basically checking what the new state is. So we can say if new state equals, and then as you notice down here with these humanoid state types, this is an enum value which we can detect. So we can say if new state equals enum dot. So we can say if new state equals, and then as you notice down here with these humanoid state types, this is an enum value which we can detect. So we can say if new state equals enum dot humanoid state type dot, let's say jumping, then we can say print player is currently jumping, just like this. And I'm also going to comment out our previous print statement like so. So if we go to the game, hit play, then what we should see is every time we jump, then it's going to say player is currently jumping. And it's going to keep doing this every single time our player changes the state to be jumping for the new state, not the old one. So that's a little example I want to give with humanoid.
Mhm.
Humanoid states, and I hope that you found this to be somewhat helpful. Now, there are a bunch of methods that affects our humanoid in some way, and I'm going to show you a few of them that you might find to be useful inside your games. The first one being take damage. So basically what this does is it takes the humanoid's health and then it reduces it by whatever we specify inside the parameter. A few of them that you might find to be useful inside your games. The first one being take damage. So basically what this does is it takes the humanoid's health and then it reduces it by humanoid in some way. And I'm going to show you a few of them that you might find to be useful inside your games. The first one being take damage. So basically what this does is it takes the humanoid's health and then it reduces it by whatever we specify inside the parameters for take damage. So I think that part's pretty self-explanatory. So if we were to, let's say, go to our change stat script that we created previously, then what we can basically do is just say humanoid colon take damage, just like this. Open close parentheses, and we can specify how much health we want to take for our humanoids. Let's say 10 every single time we do that. Now, it's important to remember, all humanoids start with 100 health. They start with 16 walk speed, and they also start with 50 jump power. So now let's see what happens if we hit R. Then it's going to take 10 HP from our humanoid, but it's slowly going to regenerate up again. So it's at 90. Then if we do it again, start with 50 jump power. So now let's see what happens if we hit R. Then it's going to take 10 HP from our humanoid, but it's slowly going to regenerate up again. So it's at 90. Then if we do it again, it's at 80, 70, 60, 50, 40, 30, 20, 10, and then we're dead. Now, once again, all this is being done inside the local side. I don't really encourage you to try doing this on the local side. You could do it on the server side. But this is just a 50, 40, 30, 20, 10, and then we're dead. Now, once again, all this is being done inside the local side. I don't really encourage you to try doing this on the local side. You could do it on the server side. But this is just to demonstrate, like, as an example of how we would be changing our humanoid states. You can even just like send this to the server as well, just to handle making changes to our character as well. But that is one method that I can show you, which takes damage. Now, another method that's pretty useful is the sit method, which basically allows our character to sit forcefully onto a vehicle seat or a normal seat. So basically, what these seats look like is if I were to go into workspace and hit the plus sign, and let's say we insert a seat. So this is what's called a seat object or a seat instance, where when the player touches this part, then the player sits on this part just like this. We can forcefully make this happen through a script just by simply going to our forcefully onto a vehicle seat or a normal seat. So basically, what these seats look like is if I were to go into workspace and hit the plus sign, and let's say we insert a seat. So this is what's called a seat object or a seat instance, where when the player touches this part, then the player sits on this part just like this. We can forcefully make this happen through a script just by simply going to our scripts that we created. Let's locate our seat inside the workspace. What I'm going to do is just say local seat equals game.workspace colon wait for child seat just like this. So we say seat colon sit open close parentheses, and then we pass in the humanoid just like this. So this is how the sit method works. Okay. So if we hit R, then we should automatically child seat just like this. So we say seat that we created. Let's locate our seat inside the workspace. What I'm going to do is just say local seat equals game.workspace colon wait for child seat just like this. So we say seat colon sit open close parentheses, and then we pass in the humanoid just like this. So this is how sit method works. Local seat equals game.workspace colon wait for child seat just like this. So we say seat colon sit open close parentheses, and then we pass in the humanoid just like this. So this is how the sit method works. Okay. So if we hit R, then we should automatically be placed on the seat right over here. So that is basically how we use this sit method. So that's a little something that
Mm.
hopefully you find useful to be in your game as well. Not only does this work for seats, but it also works for vehicle seats as well if you're trying to drive a vehicle, and generally just for things like that. Now, one more method that I'm going to show you that might be useful is the move to method, which basically allows a character to move in a certain direction by walking towards it. Not necessarily teleport to it, but walk towards it. So this is how it's going to work. Let's say we had an NPC that's trying to walk towards a specific point or a position inside the game. We would do that by using this humanoid method called move to. And there's actually two move to methods, but I'll explain the second one just a little bit. So what we're going to do is I'm basically going to go to view, go to toolbox, and we're going to find an NPC, which actually there's one right here. If I were to just click on this and insert this noob inside the game, just like so, we want this noob to walk to a specific position inside the game. The way we can do that is, let's say we insert a part inside the workspace like so. So we're going to call this one point part, just like that. And then for our noob, what we're going to do is insert a script. So I'm going to hit the plus sign, insert a script just like this. I'm first going to locate the character by saying local character equals script here, and then part, just like that. And then for our noob, what we're going to do is insert a script. So I'm going to hit plus sign, insert a script just like this. I'm first going to locate the character by saying local character equals script here, and then we're going to say local humanoid equals character colon wait for child humanoid. Now, in order to see this change, what we're going to do is make a task.wait for, let's say, about 2 seconds at the very start of the script. So next thing we're going to do is I'm just going to make a print statement over here really quickly just to say move to the part just like this so we can see the change, and then finally we're going to make reference to our point part by saying local point part equals game.workspace colon wait for child point part just like this. And so now what we're going to do is use our move to method by saying humanoid colon move to open close parentheses. Now we are going to pass in the position property of the point part and not the point part itself. So we're going to say point part dot position just like this. And
Wait, can I make it like move to me? Hey, hey, no, it's killing me. Ah, Okay, that's cool. Mm, okay.
And so now, if we
Move to.
go into the game and hit test, and if we actually hit run, then we should be able to see this. After we wait about 2 seconds, then as you can see, the noob is going to attempt to move to this location right here. Now, this isn't using something like pathfinding or anything like that. This is a more basic way of just getting a character to move to a specific point. I will talk about pathfinding in the future tutorial, but this is kind of a basic way for a humanoid to be able to try and attempt to move to a part. Because if, let's say, there was a huge wall that was blocking it, like, let's say it looks like this, then this will actually prevent the character from moving to the part that's supposed to go to. So if we wait about 2 seconds here, then it's going to, I believe, it's going to keep trying. Yeah, it's going to try until it moves to the position that it needs to go to. Oh, wait, no, it looks like stop now. Okay, so it looks like stop after trying for a bit. I guess that's how it works. I'm not really sure. But that is a method that you can use as well. Now, there's two move to methods, and it's actually important to understand the difference between the two. So there's the humanoid move to method, but then there's the character move to method that basically teleports the player or the character to where the position is located. So the difference here is if I were to comment this out, and if I were to take the position here, and if I were to go to the game and hit run just like this, then after about 2 seconds, what we should see is the noob got teleported to this part using the character move. A human move to makes the character attempt to walk towards this part. So there's a clear difference between the two, and I want you to understand that character move to is not the same as human move to. So I think it's important to know when to use either of these move to. So that's something I want to add here, and I hope you found these methods to be useful for humanoids when you're inside the game. So for this last part of the video, we're going to make a double jump system inside the game. So basically, if you're jumping and while you're in the air, you can press space again to jump while you're in the air, and that's what's called double jumping, which is utilizing humanoid states to basically detect what state the character currently is in and how we can manipulate the states so that they can jump while they're in the air. So that's what I'm going to show you how to do here. But before we do, there's actually a couple things I forgot to mention with states. So if I hit stop and if I were to quickly go to our state change script, there's two things we can do with our humanoids to, first of all, detect what our humanoid state currently is, and second, to forcibly change the states whenever we want inside our script. So if I were to, let's say, make a task that way for about 3 seconds, and if I were to, let's say, check on what the state currently is. So if I were to say if humanoid colon get state open close parentheses. So this is a method that basically returns what the current state of the humanoid is. And if I compare this to enum.humanoid state type dot let's say running, then we're going to force the player to jump upward. So what we're going to do is say humanoid colon change state, just like this, open close parentheses, and we're going to pass it here is going to be the new humanoid state.
Hmm.
Type. So we're going to call this one jumping. So now we go to the game to play. After we wait about 3 seconds, so I don't have my hands on the keyboard. And as you saw, I jumped as a result of waiting for 3 seconds to see that my character was currently running. So that's essentially how we not only detect what the current state of the humanoid is, but also how we can force change the state. So that's really important for when we create our double jumping script. So now what we're going to do is hit stop, and we're now going to recreate our double jump script. So what we're going to do is go to start character scripts, and we're going to insert a local script just like this, and I'm going to aim this to double jump, just like that. So there's a couple things we need to make references to. First thing is user input service. I'm going to say local user input service equals game service, user input service like that, and I'm going to locate the character by saying local character equals script out here. And then the humanoid equals character, wait for child, humanoid, just like this. Now there's going to be two variables that we're going to use that are important. The first one is going to be the time that elapsed since our last previous jump, so that we can use that variable to calculate how long of a difference there was between the previous jump and when we currently jump. I think it's will make more sense when I actually show you this, but basically time that elapsed since our last previous jump, so that we can use that variable to calculate how long of a difference user input service like that, and then we locate the character by saying local character equals script out here. And then the humanoid equals character, wait for child, humanoid, just like this. Now there's going to be two variables that we're going to use that are important. The first one is going to be the time that elapsed since our last previous jump, so that we can use that variable to calculate how long of a difference there was between the previous jump and when we currently jump. I think it's will make more sense when I actually show you this, but basically we're going to do say local previous jump equals, and we're going to set this to tick, open parentheses just like this. Which basically returns the number of seconds that passed since the unity time. Now, if you remember from our time episode, I do not encourage you to use tick, but just for the simplicity of this script, I'm going to show you tick first, and I'm going to show you the method that I recommend. So now, next thing we're going to do is make a boolean by basically determining whether the player currently is double jumping or not. So we're going to say is double jumping equals false, because that's what's going to be by default. So these are what we're going to be needing for the remainder of our script. Okay, now we're going to add a humanoid.state change event, which gives us the old state and the new state. So we're going to connect this with a function, and we're going to pass in our old state and our new state like so. So we're going to do check for our new state for two things. First thing is old state and the new state. So we're going to connect this with a function, and we're going to pass in our old state and our new state like so. So we're going to use check for our new state for two things. First thing is our new state being if we landed on the ground. So if new state equals enum.humanoid state type landed. So this is basically when the player touches the ground, was a jump and a fall. So if this happens, then what we're going to do is set is double jumping equal to false, because if we are, let's say, jumping, and then we jump again for double jump, and then we finally land on the ground, then that enables the player to double jump again. So that's why I have this here. But next thing is detecting our new state if we are jumping. So we're going to say else if new state equals enum.humanoid state type jumping. Then so we're detecting if the player is jumping, and if this does happen, then we're going to set previous jump, and it's going to be the current time that has elapsed since the unity humanoid state type jump. Then so we're detecting if the player is jumping, and if this does happen, then we're going to set previous jump, and it's going to be the current time that has elapsed since the unity time. So if we were to let's say previous jump equals tick open parentheses, that basically we are resetting previous jump to be whatever the current new time that has elapsed since the time is. So this is our humanoid state change event that we have here. But now we need to add functionality to when we jump by using user input service. So we're going to do say user input service input began connect function open parentheses input just like this. So we're first going to check if input.keycode equals enum.keycode.space. So we're going to be jumping down. Then we're going to basically detect whether we are going to be double jumping or if we're going to be resetting any of our variables that we had here. Okay, now for this part, we need to use our previous jump variable and also utilize tick in general to figure out like when we're able to double jump given the time that we press space to enter into our new jump from the previous one. So basically what I'm trying to explain here is being able to detect if the player pressed space quick enough to be able to do the double jump. And so this is basically what it's going to look like. So we're going to do a conditional here by saying if tick open parentheses. So this is going to return the number of seconds that passed since the time, and we're going to subtract this with the previous jump duration that we specified up here at the very beginning. And then we need to add
If that time don't know.
adding a buffer time here, which is a threshold to say like, okay, if the player jumps quick enough during this period, then we're going to allow the player to double jump. So in this case, our buffer time can be 0.2. Then we're going to hit enter just like this. So to further explain what this does, if we let's say had a ridiculously big number like this is going to be the unit epoch time for our previous jump. And so if I were to basically just copy this and do the same thing down here, and let's say this was 0.6. So this is tick, which is right here. Previous jump is this, which is our previous time that we had over here. If we subtract these two, it's an extremely marginal size difference. It's a very small difference, but it's enough for us to determine if the player is eligible to double jump. I hope that this analogy has made you understand it a little bit more with like the concept out here. So now we have that understanding. We're first going to check an extremely marginal size difference. It's a very small difference, but it's enough for us to determine if the player is eligible to double jump. I hope that this analogy has made you understand it a little bit more with like
Condition does not determine how quickly the player should jump between jump instances. It specifies how delayed both jumps should be. Yeah, yeah, that's true. Okay.
these concepts out here. So now we have that understanding. We're first going to check if the humanoid state, so we're going to get the state of the humanoid. We're going to say if the humanoid state is equal to falling. So humanoid state type dot falling, or no, free falling. So free falling, this is the state that we're going to use. So we're also going to say and not is double jumping then. So basically what this condition does is it checks if the player is currently falling. After the jumps. And
Okay, if data millis, then humanoid dot get state. If the get is if it is still free falling, and the double jumping is still false, then if double jump is true,
if the player has not double jumped yet. So then what we're going to do is say
the change there.
is double jumping equals true. And then finally we're going to say humanoid colon change state open parentheses, and then we're going to make the player jump again by putting in enum dot humanoid state type dot jumping just like that. And we have our finished double jump script just like this. So if we go to the game to play, then what we should see is we're in the game, and we're just going to let one of our previous scripts make this. So I'm going to hit jump, and it looks to be working just fine. But if I double jump, it's going to work. And once we land on the ground, that's when we're able to double jump again. So I can't like spam the double jumping because it's only allowing me to do it once. And so this is basically how we use humanoid states to make a double jumping. Script, and I hope you found this helpful. Okay, now before we end this episode, I did promise that I was going to show you the other way of utilizing time that doesn't require tick is tick is dedicated. We're going to utilize date time for this. So what I'm going to do is replace tick with date time. Okay, now before we end this episode, I did promise that I was going to show you the other way of utilizing time that doesn't require tick is tick is dedicated. We're going to utilize date time. So what I'm going to do is replace tick with date time dot now open parentheses, and we're going to get the unit timestamp in milliseconds, and we're going to divide that by 1,000 just like this. So any time that we had tick, we're just going to replace this with this calculation date time dot now. In milliseconds divided by 1,000 just like this. Now why is this calculation like the way it is? Well, if we're trying to get the unit timestamp in milliseconds, this gives us a more accurate representation of how much time has passed since the unit epoch time, because it's not going to give us a whole number like this. It's actually going to give us like a more accurate number if we do it in milliseconds. And if we divide this by 1,000, then it's going to give us an accurate tick representation of how much time has passed in, like, let's say this decimal format right here, rather than a whole number like this. So when we do this calculation, it basically does the exact same thing as we did with tick, but instead it's more reliable and accurate because it's based on universal time rather than what are the time zones for that person. Again, this all goes back to my time episode, but this is how you utilize the new
Why do we need to divide by 1,000? Can you say like Unix timestamp? If no millis, it will be 0.5, no? Oh, it's between 0 and 1 now. I see, I see. Okay, I understand.
new way of time instead of using tick. So that is basically the video of this episode. If you're still confused about time, you can go ahead and watch my time episode that I will have for you right here to watch. So go ahead and do that. If you enjoyed it, then be sure to leave a like and subscribe. And I will see you in the next episode. Take care. Newbert, can you actually just get out of my way so that I can play the game like I'm supposed to? Like I can't do that while you're here standing in front of me. Okay, what do you want, Newbert? Wait, your journey will be tough. You should take me with you. What do you mean by that, Newbert? Oh, wait, what's this? Newbert companion, $2.99 per month. Let Newbert join you on your journey. I didn't know you were some crazy salesperson, Newbert. I'm not taking your offer. Okay, how does that make you feel? Oh my god, no, stop showing me the subscription. I do not want to be. I do not want you as my companion. Okay, stop showing me this. Okay, well, it looks like Newbert is going to move unless I buy subscription. So fine, Newbert. I will pay for your companion subscription. Let's click this and oh, he's gone. Oh wait, why am I moving so weird? Wait, what the heck, Newbert? What are you doing, bro? Wait, is this what you mean by companion just being attached to my back like this? Bro, this is more of an inconvenience. Why did I even buy that?
When I wake up, I will like continue studying. Then time to like edit video. Then see you guys. Bye bye.